Okay, so now that we know how to gather data and look at data, we're going to use that data to put it into picture graphs. So it says, Tess has a game with letter tiles. Now each tile shows one of the letters A, C, S, or T. And she wants to make a picture graph showing the number of tiles with each letter because this is too much to look at. So she wants to simplify it and put it in a graph. So part A says, how many tiles have the letter A? This is pretty easy. You're going to count the letters. I see 5, 10, 15, 20 A's. How many tiles have the letter C? 5, 10. How many tiles have the letter S? So I'm just counting right now. That's all I'm doing. 5, 10, 15, 20, 25. This is going to set us up for a data table. How many tiles have the letter T? 5, 10, 15. So I'm noticing a pattern in these numbers. Do you guys notice anything? Hopefully you notice that each number ends in 0 or 5, and that's going to actually help us make our key later. So how many tiles are there in all? In all is that keyword that's going to tell me that I'm adding. So I'm going to add 20 plus 10 is 30. 30 plus 25 is 55. And then 55 plus 15, if I didn't know how to do that in my head, 55 plus 15 is 5 plus 5, 70. So you should have 70 tiles in all.
Right.
Now suppose that Tess uses this key that each box stands for one letter tile. How many pictures will she have to draw on the picture graph? Now, if each of these squares stands for 1, how many pictures is she going to have to draw? She's going to have to draw 70 pictures if each one of those stands for 1. Now, how can she change the key so she can draw fewer squares? We have 70 tiles here, and remember the key can stand for whatever we want it to stand for. So we have to think what number is going to make the most sense. It could be whatever number you want it to be. So I may pick something like 10. So that means that each square is going to stand for 10 tiles. Now it says explain. I chose 10 because 70 is a factor of 10. So each tile could be like 10, 20, 30, 40, 50. And that lessens the amount of tiles or pictures I have to use in my picture graph. You could have also used 5. 5 is good. So 10, 5, and 1 is too small. Okay, this kind of gives a rundown of how to take the data that we gathered and put it into a table. So it says that she makes the picture graph shown right here, and she's using these tiles to represent 5 tiles. Now remember, she had 70 tiles. So she's making each of these squares stand for more than 1 tile. If she did 70, that means that there would be really, really long lines of squares, so we have to make them smaller. It says that you can show the same data on a bar graph. So picture graph, bar graph. The numbers along the bottom of the graph is called a scale. It marks off the sections. And this has a scale of 5, because I see that it skipped counting by 5. So that's how to take data from a table and put it into a picture graph or a bar graph. Now, Describe when you would use a scale greater than 1 for a bar graph. I'm going to let you guys answer this question because it's a reflect question. So when would you use a scale greater than 1 for a bar graph? Would you use a scale of 1 for our data up here? Let's think about it. Okay, now we're actually going to dive into making our own picture graphs. So it says that Robert records the different bugs he sees. He wants to draw a picture graph using the data in the table. How can Robert make a picture graph? So Robert's in this position where he has his data collected, but he doesn't like how big his numbers are. So he wants these numbers to stand for something. He wants to make a key. So there are two different ways that you can do this. You can use a picture or you can use a model. When you're using a model, you're using multiplication or division to figure out your scale. So say that each bug stands for 2 bugs. My ant has 16 bugs. There are 16 ants. And I have a scale of 2. I'd be doing 16 divided by 2 equals 8. Now, when we're creating picture graphs, we have to think about not just the scale and the key, but we have to think about the titles as well. So what's a good title for Robert's picture graph? You get the title from what the information is trying to tell you. So I may have to read the problem again and figure out my title. He records the different bugs that he sees. Okay, so this is telling me about the bugs that Robert saw. So I'm gathering my title from the question itself. So I'm going to call it Bugs Robert Saw. Now, they were super nice and they went ahead and they actually did the picture graph part for the ant and the bee. And we have to finish up doing the moth and the spider. So I'm going to go ahead and fill those in because those are my 2 other bugs. Now, if I know that there were 16 ants that Robert saw, but he only has 1, 2, 3, 4, 5, 6, 7, 8 pictures, that means that each one of these pictures has to stand for some number. So there's 8 of those, 16 total ants. I'm going to think, okay, what's 16 divided by 8? And I know that's 2. So I know that my scale or my key has to be 2 bugs. So each of these pictures is going to stand for 2 bugs. Now the bee I see has 4. There are 4 bees. So it's like saying 2, 4. Now moth, there are 6 moths. So how many bugs am I going to have to put for moth? I want you to go ahead and do moth and spider using our new key. Remember that each bug stands for 2 bugs. And if you have 6 for moths and 12 for spiders, how many bugs are you actually going to have to draw? I'll give you a couple seconds to figure that out. So why does a scale of 2 work better here than a scale of 1? A scale of 1 makes it harder to do a picture graph because that would mean for the moths, for instance, you would be drawing 6 bugs, or for the ants, you'd be doing 16 of these. So it would make for a really, really, really big picture graph because it would be really long. So the next section is our try it section, and normally I would make you guys try this on your own. This would be like our challenge question. So you're being challenged right now to use this data from the table and put it in a picture graph. You have to title that picture graph and create a scale.